August 1944. Isigny, France. 12th United States Army Group Ordnance Teams. Lieutenant General Omar Bradley commanding. Core metric: the 76mm M62 armor-piercing capped projectile was rated to penetrate about 93mm of armor at 500 yards against plate set at 30 degrees from vertical. Captured Panther hulls and turrets stood on the Normandy range. Ordnance officers marked firing lines at measured distances. Test guns opened with standard 76mm M62 armor-piercing capped ammunition at a muzzle velocity of about 2,600 feet per second. Rounds were directed against the Panther upper glacis, a thick sloped plate, and recorded impacts failed to achieve reliable penetration at the ranges used in the trial. The pattern confirmed field reports from Normandy that 75mm Shermans and the newer 76mm guns with ordinary ammunition had great difficulty defeating Panther frontal armor. Technicians then loaded the experimental T4 high-velocity armor-piercing shot. Each projectile used a dense tungsten carbide core inside a lightweight full-caliber aluminum body with a steel base and windshield, fired at approximately 3,400 feet per second. Test crews again engaged the Panther frontal components. Under the same conditions, T4 impacts on the 100mm cast turret front and mantlet produced clean perforations where standard rounds had failed. The tungsten-cored projectile achieved penetration figures on 30-degree plate at 500 and 1,000 yards that were far higher than M62, matching its tabulated values of more than 150 millimeters at 500 yards and more than 130 millimeters at 1,000 yards. Every strike and resulting hole was photographed, measured, and entered into the firing report. American crews quickly recognized the new round by the distinctive light-colored band around the projectile body, a visual marking that led to its nickname as the silver-banded shot. The Isigny board concluded that standard 76mm ammunition remained inadequate against the Panther frontal armor at normal combat ranges, but that the T4 round provided a limited yet genuine capability against the PT, turret, front, and mantlet. On that basis, Ordnance arranged for 1,000 rounds of the new 76mm high-velocity armor-piercing shot to be flown to the European theatre for further testing and issue. Crews waiting in forward assembly areas would soon see crates of the new tungsten ammunition marked for priority distribution. Summer 1944 to winter 1945. Normandy, Lorraine, Ardennes. United States 1st, 3rd, and 9th Armies, opposed by German 5th Panzer Army and 6th Panzer Army. The standard reference remained that the 76mm M62 armor-piercing capped projectile could penetrate about 88mm of armor at 1,000 yards against plate set at 30 degrees from vertical. American armored divisions pushed through dense hedgerows and then across rolling grain fields. Panther companies appeared in increasing numbers behind ridges and village edges. Each German tank carried the long 75mm Quebec 42 gun, rated in trials as capable of defeating M4 frontal armor at ranges beyond 2,000 yards and giving German crews a marked advantage in engagement. Distance. The Panther upper glacis plate measured about 80mm thick and was sloped at roughly 55 degrees from vertical. The rounded cast mantlet added about 100mm of variable thickness armor directly in front of the gunner. Most United States tank crews still fought in M4 medium tanks, armed with the 75mm M3 gun. At 1,000 yards, it offered significantly less penetration than the newer 76mm weapon. Frontal duels against Panthers often ended quickly and badly. Sherman platoons learned to swing wide for side shots or call for tank destroyer support. Doctrine reserved the primary anti-tank role for separate battalions, equipped with towed 3-inch guns or self-propelled M10 and M18 mounts. The fast M18 Hellcat brought 76mm guns into widespread use during the summer pursuit across France. German commanders placed their Panthers to exploit their frontal protection and gun range. Hull-down positions on reverse slopes became routine. American losses rose whenever infantry failed to clear the way, or artillery could not suppress the defenders. Ordnance pushed additional 76mm armed vehicles forward, Yet the standard M62 round still failed against the Panther glacis at normal engagement distances. Crews waited for a projectile that would finally give them a realistic chance from the front. From inside a Panther, the battlefield looked different. Commanders watched American tanks advance in short bounds, pausing behind hedgerows, smoke or folds in the ground. Early in the Normandy, fighting hits from 75mm guns usually left only bright scars on the glacis or mantlet. Crews reported sharp impacts, ringing armor and spalled paint, but no penetration. That experience reinforced the belief that if they held their hull-down positions and kept the range open, Allied fire would remain survivable as long as the thick frontal plates stayed between them and the enemy. European theatre ordnance laboratories and proving grounds in 1944 and 1945 compiled comparative firing tables for the 76mm gun. Those tables recorded that the high-velocity armor-piercing round for the 76mm M1 could penetrate about 134mm of armor at 1,000 yards against plates set at 30 degrees from vertical. The 76mm M1 gun fired the steel M62 armor-piercing capped projectile at about 2,600 feet per second. Against armor inclined 30 degrees, that round penetrated approximately 93mm at 500 yards and about 88mm at 1,000 yards. The Panther upper glacis consisted of roughly 80mm of rolled homogeneous armor, sloped at about 55 degrees from vertical, a combination that firing tests and later analysis found to be beyond the penetration of the complete M62 round at normal combat ranges. Standard ammunition was regarded as ineffective against that plate, except at very short distances, under favorable conditions. Technicians then evaluated the tungsten-cored high-velocity armor-piercing shot, later standardized as M93 HVAP. The projectile used a dense tungsten carbide core carried in a full-caliber lightweight metal body and was fired at roughly 3,400 feet per second. Against the same 30-degree target, its penetration values rose to around 157mm at 500 yards and about 134mm at 1,000 yards. In controlled firing, the tungsten core produced clean perforations where the steel projectile had failed. Panther turret fronts carried about 100mm of cast armor with some variation in hardness, while the mantlet reached similar or greater thickness in its curved sections. Side hull armor was on the order of 40mm on the upper side and 50mm on the lower side, set close to vertical. Firing tests and post-war ballistic analysis showed that the 76mm high-velocity armor-piercing round could penetrate the Panther turret front and mantlet under suitable ranges and impact angles, that the side armor lay within its penetration envelope at typical engagement distances, while the upper glacis generally remained resistant. Late in 1944 and early in 1945 in the European theatre of operations, ammunition depots and forward units handled the new 76mm high-velocity armor-piercing shot in very small quantities. Theatre-level records show that before March 1945, the average 76mm gun received fewer than 2 such rounds per month. The first experimental consignment of roughly 1,076mm high-velocity armor-piercing rounds was flown from the United States to the European theatre in the late summer and autumn of 1944 for test and initial issue. Additional air shipments followed, but tungsten remained one of the most closely controlled materials of the war, and production of cores in the United States had to serve several calibers and several theatres at once. Total output never caught up with the number of guns that could fire the new ammunition. Tank destroyer battalions armed with the M18 Hellcat received the earliest and highest priority allocations. Their mission was to move quickly and engage German armor at long range in open country, and ordnance staff judged that the improved penetration of the tungsten shot was most valuable in that role. Tank companies equipped with 76mm Shermans began to receive their own small stocks later in 1944 and early in 1945. Weekly theatre receipts rose toward about 2,000 rounds by January, still far below the total of 76mm weapons. Then in service, so that many crews saw only a handful of high-velocity armor-piercing rounds for their vehicles. At forward depots and company ordnance points, the new ammunition was handled as a scarce resource. Units recorded its arrival and expenditure separately from standard M62 steel armor-piercing shells. Vehicles that did receive tungsten shot usually carried only a few rounds alongside a much larger stock of conventional ammunition, and company and platoon leaders directed that the high-velocity armor-piercing rounds be reserved for engagements with the heaviest German tanks at ranges where their additional penetration could be fully used. Combat zones on the Western Front in 1944 and 1945 placed United States 76mm equipped units opposite Panther-equipped Kampfgruppen. Open plains in Lorraine and the frozen fields of the Ardennes offered sight lines that could stretch to more than 1,500 yards, while bocage lanes and ruined villages forced engagements down to 300 yards or less. Terrain dictated the ranges at which 76mm gunners and Panther commanders met each other. Panther crews used ground that allowed hull-down positions on reverse slopes, exposing mainly the thick turret and the sharply sloped upper glacis that had resisted steel armor-piercing shells since the summer of 1944. American crews learned to look for folds in the terrain that might permit a shot at the lower front hull, or for flanking routes that opened the side armor, once infantry and artillery pushed German units off dominant ground. When 76mm guns were issued, high-velocity armor-piercing rounds, gunners waited for the rare combination of angle and distance, where the tungsten shot could be used to best effect. The round left the muzzle with a sharper report than standard ammunition. Test results and combat experience showed that at several hundred yards, it could penetrate the Panther turret front and mantlet under favorable conditions, and that the 40mm and 50mm side plates were vulnerable whenever the hull presented a broader aspect. The upper glacis, however, remained a difficult target and generally continued to resist 76mm fire at ordinary engagement ranges. Analyses of knocked-out Panthers identified clean perforations on turret fronts and side plates consistent with high-velocity armor-piercing rounds alongside many impacts from which standard steel projectiles had ricocheted or shattered. German crews noticed the change before they understood the physics behind it. In late 1944, reports from Panther units in the West began to mention clean holes punched through turret fronts and mantlets at ranges where earlier hits had only gouged the steel. Commanders who had trusted the thick cast armor in front of the gun now found vision blocks shattered and loaders wounded by fragments. Side plates that had once stopped most medium-caliber fire were holed neatly when tanks were caught traversing or crossing open ground. Word spread through companies that the Americans were firing a new, harder projectile, and that exposing the turret or flanks, even for a moment, carried greater risk than it had a few months before. Studies of German armoured losses on the Western Front indicate that many Panthers were destroyed by artillery anti-tank guns, mines, infantry anti-tank weapons, air attack, and mechanical breakdown with tank gunfire, making up only part of the total. Within that portion, 76mm high-velocity armor-piercing ammunition formed only a small share of the rounds fired. Crews that carried a few tungsten rounds had an additional option when confronting Panthers from the front at suitable ranges, but most engagements still depended on combined arms tactics, careful use of terrain, and attacks against the sides and rear of German tanks rather than on frontal penetration of the upper glacis. United States Army Ground Forces and European Theatre Headquarters began to incorporate the results of the 76mm firing trials into tactical guidance during 1945. Reports from the Isigny tests and subsequent ballistic analysis made clear that the high-velocity armor-piercing shot offered a significant improvement against the Panther turret, front mantlet, and side armor at certain ranges, angles, while the upper glacis remained a very difficult target. Field instructions and training material emphasized that tank and tank destroyer units should continue to seek flanking positions whenever terrain allowed, and that artillery and fighter bombers remained the preferred means of engaging concentrations of heavy German armor. The 76mm gun, with high-velocity armor-piercing ammunition, was treated as one element inside a broader combined arms approach, rather than as a standalone solution to Panther frontal protection. Within armored and tank destroyer battalions, the new tungsten-cored round was issued in small quantities and was normally recorded separately from standard M62 steel armor-piercing ammunition. Crews were told to reserve it for confirmed heavy targets, such as Panthers and Tigers at moderate ranges, where hits on the turret front mantlet or lower front hull were most likely to produce a penetration. Firing at the Panther upper glacis with the 76mm gun was generally discouraged, except at very short range, since tests and combat experience both showed that even the improved projectile had little chance of success against that plate under typical conditions. German and Allied post-war studies of armoured combat on the Western Front noted that Panthers were lost to a wide variety of causes, including artillery, anti-tank, guns, mines, infantry, anti-tank weapons, air attack, mechanical failure, fire from other tanks. High-velocity armor-piercing rounds for the 76mm gun accounted for only a small fraction of German tank losses. The round narrowed the set of angles and ranges at which United States crews could challenge Panthers from the front, but did not eliminate the need for maneuver, supporting arms and attacks against the sides and rear of German vehicles. In intelligence and historical summaries prepared near the end of the war, and in the immediate post-war period, the 76mm tungsten-cored projectile appears as a specialized but limited tool. It improved the prospects of turret and side penetrations against heavily armored German tanks when carefully employed. Yet the overall assessment remained that combined arms tactics and numerical and logistical advantages, rather than any single ammunition type, decided the outcome of the campaign in the West. The war in Europe ended in May 1945, with the 76mm high-velocity armor-piercing round only recently in service and available in limited quantities. Stocks of ammunition for the 76mm gun, including tungsten-cored rounds, remained in depots when combat in the European theatre stopped. The gun and its ammunition continued in service after the war and were employed again in the Korean conflict, where 76mm armed tanks using high-velocity armor-piercing shot were able to defeat the armor of T-34-85 tanks at typical combat ranges, when crews had adequate training and when suitable ammunition supplies were available. Post-war technical work at Aberdeen Proving Ground and other ordnance establishments reviewed wartime firing trials and repeated ballistic tests. These studies confirmed the penetration figures already established in wartime tables for the 76mm gun. The standard M62 steel armor-piercing capped projectile penetrated on the order of 88mm of armor at 1,000 yards against plate set at 30 degrees from vertical, while the tungsten-cored high-velocity armor-piercing shot achieved roughly 134mm under the same conditions. The reports concluded that the tungsten round offered a clear improvement against heavily armored areas such as turret fronts, mantlets, and side plates on German tanks when impact conditions were favorable, but they also noted that the Emensche, well-sloped upper glacis of the Panther remained highly resistant to 76mm fire at normal engagement ranges. Broader historical studies placed the 76mm high-velocity armor-piercing ammunition in context. About 6,000 Panther tanks were built in total, and they served on both the eastern and western fronts. Wartime and post-war analyses alike indicate that many Panthers were lost to causes such as artillery, fire, anti-tank guns, mines infantry, anti-tank weapons, air attack, and mechanical failure, with tank gunfire, accounting for only part of tank. The total. Within that portion, rounds from 75mm and 76mm guns firing conventional steel projectiles as well as high-velocity armor-piercing shot all contributed to the overall figures. Flank and rear shots and engagements at short range where terrain or visibility compressed the fighting remained the most common conditions under which Panthers were destroyed by other tanks. In assessments written in the late 1940s and early 1950s, the 76mm tungsten-cored projectile appears as an effective but limited measure that extended the useful life of medium caliber guns against heavily armored opponents. It increased the number of situations in which United States crews could attempt frontal fire against vehicles such as the Panther and improved their chances of penetrating turret and side armor at certain ranges, yet it did not remove the need for maneuver supporting arms and numerical superiority. Later, tanks armed with 90mm and larger guns, together with changes in design and fire control, gradually replaced the 76mm system in frontline service. The Panther's sloped frontal armor continued to be cited in post-war literature as an important example of how geometry and protection could offset the performance of many contemporary anti-tank weapons. At the same time, studies emphasized that overall outcomes in the West were determined more by production capacity, logistics, air and artillery supremacy, and the coordination of infantry, armor, and supporting arms than by any single type of projectile. The introduction of high-velocity armor-piercing ammunition for the 76mm gun narrowed certain tactical gaps and gave well-trained crews an additional option when range, angle, and ammunition supply aligned, but it remained one factor among many in the broader balance that decided the campaigns. For Panther crews, the appearance of the silver-banded 76mm shot narrowed the angles from which they could rely on their armor. Turret fronts and side plates that had once been trusted now demanded stricter discipline in choosing hull-down positions and exposing only the thickest plates to fire. The war, however, was not decided by any single projectile. Production logistics, air superiority, artillery, and combined arms tactics did more to empty Panther companies than the limited stocks of tungsten-cored ammunition issued to a minority of American guns.